Right, this is a presentation I created in 2010, I think. I thought I'd record it now, just in case anyone finds it useful. It's about a half hour. It's called Code Design, and that's me. So who am I? Well, I joined the industry the game industry in 1993. I joined a company called Signosis, which some old timers might remember. I was there for 5 years as a programmer. I left Signosis as a kind of senior programmer, lead programmer. Me and a few friends did Curly Monsters as a startup. Worked with Microsoft on the original Xbox. Then after that I went to EA for 6 months. Then back to Sony Liverpool for 6.5 years. And I was there for most of the time there. I was a senior programmer, stroke tech director for a team. Then I started at Bazaar at March 2010, and then when Bazaar got closed down by Activision, I started my own company, Curly Rocket, in February 2011, and it's now 2014 in February, so that's been around 3 years, and I've been contracting and working for a few different companies. Currently the major thing I'm doing is I'm working with Playwright Digital, which is pretty cool. So let's just jump in anyway. So this talk it's about general code topics really. There'll be a few specifics I'll talk about. Ideally this is stuff you already probably know, but it's always good to go through these issues and keep it fresh in your mind. Alright, that third point isn't really relevant, seeing as this is a video. If we and that last point's gone as well. So, a few topics I'm going to run through. Technical debt, which is a nice concept. Code complexity, maintainability, languages, metaphors, patterns, style, layout and comments, and API design. So they are all... I'm not going to drill into any language specifics particularly in any of this. These are just general things that you need to be aware of to be a competent programmer, I think. So technical debt. What is technical debt? Technical debt is the consequences of slapdash software architecture and hasty software development. And if you look on Wikipedia, that'll tell you shipping first-time code is like going into debt. A little debt speeds development, so long as it is paid back promptly with a rewrite. The danger occurs when the debt is not paid. Every minute spent on not quite right code counts as interest on that debt. Entire engineering organisations can be brought to a standstill under the debt load of an unconsolidated implementation. I think anybody listening to this who's worked on a big team or a big project that has inevitably come across technical debt, and I think you'll agree that that last line, where organisations can be brought to a standstill, is, it rings true. A bad code base can be an absolute pig to work on, awful to maintain, be fraught with bugs, and trying to fight with technical debt at the end of a project is a real killer, and is one of the reasons why projects can slip. So where to find technical debt? Well, required knowledge that isn't shared around the company. How does the build system work? What if the guy who wrote it is off that day? What if something needs to be changed and the guy or a couple of guys who know how that bit of whatever works aren't around? Then someone goes in, hacks at it, changes it, might add something in the wrong way, in a way that it was never meant to be designed to be added to. So, required knowledge like that needs to be shared around the company a bit better. I know some programmers like to hold on to their little knowledge, make themselves indispensable, but that is a form of technical debt. Code that's too confusing or complex to be modified easily. One of the programming is difficult at the best of times. If you're writing complex and confusing code and you have to go and modify it, even if it's your own code and you've just forgotten how it worked, that is a form of technical debt, because you will only make things worse. Ideally, if you're going to modify or extend code, it should be easy and you should understand it before you touch it. Code that lacks needed documentation. I think that one's pretty obvious. If you can't see how a piece of code is meant to work or what the architecture of it is because it's undocumented, then you're probably going to miss a few things if you dive in there and start fiddling with it. code that hasn't been robustly tested through all execution paths. I mean, everybody's written code and it works for me, it works on my machine. You check it in and then it breaks somewhere else, or 6 months down the line situation changes slightly and then suddenly a different execution path is triggered and it all falls apart. So you really need to test all your execution paths through your code. Unattended to-do comments. If there's to-do comments left in there and no one's looked at them for a while and they're just hanging around, then that's obviously something that hasn't been done properly. Even if that something has been done properly, the to-do comment should have been removed. So the odds are there's something that hasn't been done properly. And compiler and static code analysis warnings. I'm sure we've all worked with people who ignore warnings. A compiler warning is the compiler telling you that your code is ambiguous, and what might actually end up in your executable is down to whatever whim the compiler has in its innards. So listen, read warnings and static code analysis and fix them. In an ideal world, you would set all warnings as errors and you couldn't move on unless there were warnings, but there are instances where you can't avoid warnings. So that's not always you're not always able to just set warnings as errors. Pay debts off in a timely manner. Short-term debt is okay, long-term debt is bad. Hacking something in the night before a demo just to get it working is fine. Don't leave that code in there. Debts grow over time. They don't shrink, they grow. And technical debt is just like any other debt. You need to manage it, be aware of it, and reduce it when you have time. Managing technical debt is a task. It might not be on the task list, and your producer might not be aware of what the technical debt concept is, but tell them it needs to be done. Unattended debts grow over time. Yeah, good enough usually isn't, especially if reuse is possible. Like I say, you write the code once, it works for you, you check it in, you move on. It's good enough. Well, it'll probably be stress tested in slightly different ways in the final product, or if it does get reused for a different project, someone's going to find some chronic problems with it. So be aware of how robust your code is. Because non-fully robust code is a form of technical debt. Code complexity. When possible, try to minimize code complexity. It makes everyone's life easier in the long run. Complex code is harder to understand, harder to refactor, and usually more fragile. It's fairly self-evident. High cyclomatic complexity, which is the number of linearly independent paths through a piece of code. I'm sure everyone's seen the methods from hell with 600 line methods with just bags and bags of if this, then that, else that, if this, whatever. The number of execution paths through one of those methods is huge. So that's a very high cyclomatic complexity. Those kind of methods are normally difficult to debug, difficult to maintain, difficult to extend. So you need to reduce them. Try and encapsulate your logic a bit better. Difficult or specialist knowledge required to understand. You come along, you know some little trick of the language or some little thing that no one else does. You put it in the code base. Well, that's not good. Because if that bit of something breaks or you leave the company, then you've got a complex bit of code there which isn't really it's hard to maintain. Code which doesn't follow architecture patterns used elsewhere in the code base. That's a common one. When you join a team or you start using a code base, try and make your code fit with the existing code. Don't think, oh, this is wrong, I'll just go in there and do it my way. Because your code will stand out like a sore thumb and it probably won't follow some of the established patterns that the rest of the code base has. The end result of that is when a third person comes along to try and modify or maintain the code base, they've got two differently built pieces of code that they've got to figure out two separate ways. They have to understand your code and the original code architecture. It's much better if you just make your code fit the project you're working on. It's good practice. Poor layout, naming, and class breakdown. Yeah, don't call your variables var or value or these hugely ambiguous things just because you don't have the you can't be bothered to think of what this variable actually does. Give it a good name. Keep your layout nice. Keep your layout to fit with the rest of the code base. Again, don't come in with your, I like my brackets like this, and start doing stuff which doesn't fit the rest of the code base. Break down your classes nicely. Give them sensible names. If their function changes over their life, change the class name. There's nothing worse than trying to figure something out, and after half a day or so you realise that this class called X doesn't actually do X, it does Y, but the guy who maintained it and changed it couldn't be bothered changing it. Over-engineered solutions, don't program for the sake of it. It's a waste of time. If you want to do that, do it on your spare time. You make it as robust and as simple and as clean as you can. There's no point adding more and more logic where it isn't needed. Clever code is usually complex code. If you know some little hack of the language or some little trick that you think makes you stand out, don't use it unless it's needed. Don't be clever for the sake of it. You're not proving a point. All you're proving is that you can't work within the bounds of the rest of the team. Needlessly using some obscure or little used part of the language. Yeah, that's that kind of thing, really. Use what you need to. Don't use stuff just because you want to practice with something or play with something, or you've just read a book that mentions something that you just want to execute for the sake of it. Hacking the language. All these things are possible. Modern computer programming, modern languages are very complex and powerful, but you don't need to use all the features. Keep it simple, stupid, obvious, and spend time breaking down the code intuitively. Think before you type. Break down the files, the objects, the functions. Make sure these things are easy to understand. They're not just all in one source file with the wrong name. Some complex code is inevitable in a large project. Some tasks are complex. If you've got complex logic that needs to be used on complex data, then that's it. But document it, break it down, make the code as simple and clean as possible. Your aim is to minimize the amount of complex code. Code maintainability, very important as well. How important is code maintainability compared to other factors? Well, it depends, really. If you're just doing a quick demo, then maintainability is not that important. Speed of building the systems is much more important. If you're writing something that you expect to be reused for the next 10 years, maintainability should be top of your list. You also need to look at who's going to maintain the code. If it's a group of coders, you should plan things together. You need to make it robust. If it's just you, maybe you don't need to be quite as formal about all the process. But regardless, you've got to think about the maintainability requirements before you start typing. It's very important. Alright, so one of my answers to this maintainability, I would happily sacrifice 10 to 20% runtime performance for a more maintainable code base. I'd rather ship on time, pushing 400,000 polys, than ship late with 500,000. Gamers probably can't tell. And project slippage is very bad for publishers, i.e. the people who pay your wage. Project slippage is very expensive. One thing you really need to think about when you're writing your code in your engines is the speed of development using that code base. If you've got a piece of code which is very performant but is a pain in the backside to use on a day-to-day basis and keeps causing breaks in the build pipeline and is unintuitive and the tools aren't quite ready, then that's not good. If you can re-architect it, maybe lose a bit of the runtime performance but have a much better development environment, that's probably better. Again, someone out there will have an instance where the ultra-performant one is the one they need. Fine, at least be aware of it before you start typing. Shipping on time and to quality is the most important thing we need to do. I think that's true for all software engineering. We're in the business of selling products, not performing research or pushing hardware to theoretical limits. Damn right. If you want to do research or ultra optimization of some niggly thing, then I don't know, join a university. I don't know. I think the game industry survives on releasing games that are good fun. There are times when code maintainability isn't as important as other factors. Prototyping. You can read the last line there. Languages. Is your favourite language always the right tool for the job? It might not be. When all you have is a hammer, everything looks like a nail. but you also need to recognise when a hammer is the best tool for the job. It's very easy to get stuck in one language, probably the primary language that's used on your team. It's very good to learn other languages. You might not use them, you might use them, but different languages are built on different design metaphors and different logic metaphors. Exposing yourself to different languages teaches you new ways of thinking and breaking down a problem, because you have to break down a problem within the bounds of the language you're going to use to solve the problem. So it's very useful to learn new languages constantly. Languages evolve. There's new languages all the time. I would thoroughly recommend learning at least one language a year and try and use it on a project. If you can't use it on one of the projects that you're in, do some little side project at home, but at least get an understanding of what that language is good at. Because then, in a few years down the line, when you're faced with a problem and you need a quick solution, you'll know which language to pick. Yeah, I've just been through all this, haven't I? Expose yourself to other technologies is a great way to learn and grow. So there's loads of languages out there. Look at them. They're all designed on different building blocks. They all excel at different things and should be used in different situations. Different frameworks do things in different ways. Different platforms do things in different ways. This is all good stuff. You don't need to be an ultra guru at all of this. You're never going to be. Your brain is finite. But if you understand the limits and the ideas behind these languages and frameworks and platforms, then you're going to have a much more flexible thought process when you come to breaking down a problem. So even though you probably won't use them day by day, they should inspire you and show you new ways of thinking about solutions. There we go. Metaphors. What is a metaphor? At its best, the metaphor is a simple, evocative description of how the program works. They help people visualize the system, provide a common architectural vision, and make computation tangible. Mathematics is complex, logic is complex. If you can wrap up the way something works in a more easily digestible way, that's a metaphor. Is it client server? Is it peer to peer? There are thousands of these things. They're just a simpler way to describe how something works without necessarily needing to go into the details. Document the metaphors, put them in the comments, put them on the wiki. Grokking how someone else's code works can be tough. Help each other out. That's a very valuable thing you need to be aware. Just because you know how something works doesn't mean that the guy sat next to you knows how it works, but one day he might have to use your code. Make it easy on him. Even if you're the only programmer, your future self will forget exactly. I've looked back on the code I wrote 6 months earlier and thought, I have no idea how this works. Well, you won't remember how everything you wrote in your entire career worked, and you might have to go back and use this stuff again. So some examples: client server, manager objects, state machines, databases. These are all just ways of encapsulating behaviour without necessarily exposing the specifics. So commonly used metaphors are called patterns. Get familiar with them. They are the programmer's toolkit for solving commonly encountered architectural problems. Patterns provide a vocabulary for communicating the relationships, responsibilities, and interactions between objects. It's very important that. The vocabulary for communicating the relationships, responsibilities, and interactions between objects. That is how your game system works. That's how the code base works. Patterns provide a way of helping people understand how things work. Knowledge of patterns can help the thinking process and give insight into how to break down a problem. Once you know if you've got a lot of tools in your brain, then you can look at a problem and have a much better understanding of how to break it down to fit the requirements. Common patterns: singleton, factory, visitor, observer, strategy, delegate. These are all things you've probably used. You might not necessarily have been aware that whatever that thing you used was called the factory pattern, but once you understand and can recognize it, then it can be easier to kind of to understand how a large system works. Be sensible with them. You don't need to use a pattern for trivial stuff. And the best way to learn patterns is to look at code which implements them. Samples in books, the ones I've looked at, haven't been terribly useful. But some of the code bases I've used, talk to the guys who wrote it. If there's a good engine or a good system, some some really sweet bit of code that is nice. Talk to the guy that used it, find out how it works, understand it. Shared style reduces code ownership and makes foreign code easier to read. Like I mentioned earlier, the last thing we want is you joining a big project and thinking, ooh, I think my code looks better than this stuff. I'll write all the code I'll write in my style. Well, that makes the code base a mess. Make your code fit the code base. Good code can be self-documenting. Yeah. Old or incorrect comments are worse than no comments. Absolutely. No good reading a comment that says, oh, this does this in this way, and then you can move forward with the wrong ideas, and only when you have to drill back or fix a bug, you realise that the comment was actually leading you completely in the wrong direction. Refactor comments as you refactor the code. Comment things that are hard to express in the code. Algorithms, funky maths, optimizations, links to references. Give people a hand. Help them understand your code, but don't comment the obvious. A comment that says this is a for loop to iterate around the first 10 entries of this. That's it. That's implicit in the code they're looking at. API design. This is one of my pet ones. The API is the contract between your code and the rest of the world. It is important. Bad APIs make programming an absolute pain. Anyone used some bad frameworks or libraries in the past that are just, you end up banging your head off the wall because the API is such a mess? Good APIs make it a joy. They certainly do. If you've used a very well designed framework with a very clean API, it makes programming tasks trivial. Others are unfamiliar with your code. The API is their first point of contact. Don't make them hate you. The API is probably the most important part of your code because it defines how it fits in with the rest of the code base. Do a good job on it. You will forget your code. Help your future self. That one again. The sensibly built API will help you in this. Using your API should be simple, intuitive, and foolproof. So use descriptive naming. Spend brain power doing this. You've got functions like find, fetch, and get. They are semantically weak. You can't tell what the function is meant to do just by looking at the API. Change it. Careful using bool as an input parameter. The use may not be obvious. Enums carry more descriptive weight. And there's an example there. Update true, true, false, true, false. Who knows what that is? Use enums and people can look at your code and see much better. Too many parameters, especially with defaults, can be harder to refactor and build upon. Use an init object instead. Constructor replaces defaults. You can use this in C or C++, but with C you're going to lose the constructor, so you have to memset nil it or something. But I think you'll agree that that first line there is a bit what's going on. Use an init structure, and then when you call init, you just pass in a reference to that structure. It makes the code a lot cleaner, and you can embed defaults in the constructor of the init of the init struct. So general guidelines: clarity trumps brevity. Typing is easy, thinking is hard. Basically use nice descriptive API method names. Modern editors all have autocomplete, so typing a long function name is not an issue. Trying to debug something that's not clearly named is an issue though. So careful with granularity. Don't bloat parameter lists. If you've got an init structure, an init function which takes 26 parameters, then maybe it's worth breaking down a bit. Maintain older systems. Don't leave them to rot. Deprecate when code is old or not used. There's you can find a lot of code that's left in there just in case. Well, trim it out. Make the metaphor obvious. Document what is not obvious. Again, careful with revealing implementation details. These may change. I always think a good API encapsulates the difficulty of doing something and makes it easier for the calling code. Once people start using your code, it becomes very hard to fix a bad API. That's it. So once your code becomes part of the main code base and people start linking and binding to it, then you can't, going back and just changing the API arbitrarily means someone's going to go and edit all those calling functions. So a much better thing is to think about the API early on and try and get it as right as you can first time. remove the technical debt. Make it impossible for someone to use your class incorrectly. Tell the calling code what went wrong. Don't just abort. And that is just sensible handling of errors. Help profiling. If getID does a load of non-trivial processing, maybe change the name. Yeah, people are trying to optimize code. They do what the function is called will affect how they think the code is going to perform, if you know what I mean. Just use sensible names. Handle warnings, errors. Yeah, where does the responsibility lie for handling a warning or an error? Should your library throw an abort, or should it pass back an error statement? Should it throw an exception? Should it not? These things you got to work out at the start, so you can design your API so that the errors can be handled where they should be. Make sure you know before you think about the API how to handle errors and warnings. Test your API. Every route through the logic should return a useful value. Think what the call does for the caller rather than how the code works. Yeah? So an API should describe what service your code is providing to the calling code. If your API just describes the algorithm inside, and it's next to useless, I think. Careful with generic words which add little or no descriptive weight. Item, object, value, mentioned that before. Be very careful about overloading the meaning of a single parameter or return value. You've all seen this, where a function has one int return, and if it's 0, then that's a success. If it's negative, then that means it's this. Unless it's -2, and then a -2 means that they couldn't quite find that. A positive value is if it's, they just use references to return to error objects or something, because those kind of overloading an int to have a lot more meaning than it should have. They're very difficult to debug, and it's very difficult to build on code like that. Think everyone else is stupid. How can I make this foolproof? Clearly separate public and internal methods. Well, that's just good practice. And the more time you spend helping people debug your code, the less work you get done. Yeah, if your code is fragile and unintuitive and a bit clunky, then people are going to bug you all the time. How does this work? How does that work? If you can spend time getting your API robust, simple, intuitive, and returning all the errors, then it's going to be impossible for them to not understand what's going on. They're not going to bug you. You're going to be able to get more work done. So closing messages: keep it simple, stupid. Make APIs and architecture obvious and intuitive. Replay technical debt as soon as possible, or as soon as is realistic. And code defensively. It's not that everyone out there is an idiot, but everyone out there isn't necessarily in your exact focused frame of mind on the problem at hand, and even you in the future won't be as focused on the problem as you are now. So you've got to build your code in a way that people who are not in the zone as much can use it and build it and debug it. So I'll probably do another one of these. If anyone's got any questions, put them in the comments at the bottom. You can get in touch with me on Twitter @FizzyChicken. Yeah. Goodbye.